Hi everyone, come let's go with voltage and frequency control method. Other name of this constant voltage and constant frequency control of induction motor are constant volts and constant hertz control of induction motor. This is black diagram of voltage and frequency control method. In this black diagram, the supply frequency is changed, the value of air gap flux also gets affected. This may result into saturation of stator and rotor cores. Such as a saturation leads to the sharp increase in the no load current of the motor. Hence, it is necessary to maintain air gap flux constant when supply frequency is changed to achieve this. When a frequency is varied, voltage must be also varied such that voltage by frequency, otherwise V by F, remains constant. The speed control of three-phase induction motor mostly prefers this control method. The increase in the supply frequency increases the motor speed and also reduces the max torque of the motor. The increase in voltage results in an increase in the maximum torque of the motor. If we combine these two features, we can achieve a control design by which the speed increases and the torque is kept the same. This is known as V by F control. The change in V by F is a powerful method for a speed control of induction motor. There are several variations where V by F ratio is also adjusted to provide a special operating performances. The most common method is the fixed V by F ratio, that means voltage by frequency ratio. The torque and speed chart for fixed voltage by frequency ratio. Both the combination of ratios mentioned this graph. Time should be constant by keeping fixed V by F ratio. The relation between max torque and V by F is T max equal to K into V by F half square. From this equation, V by S maintain constant, T max also remain, and the air gap flux is also constant. The low frequency operation at a constant V by F is not satisfactory, particularly at very low frequency. Due to this very low frequency, starting torque and breaking torque considerably decreases and no load current increases. The air gap flux cannot be maintained constant at low frequency, maintaining at constant V by F ratio. Therefore, we can maintain the V by F ratio constant. The supply voltage should be increasing. The V by F control method. One must be careful not to increase the voltage magnitude beyond the rating of the motor. The increased voltage can cause instant damage to the insulation of the motor winding. So, normally the voltage should be kept below 110% of the rated value. It has some main features, or max torque should be constant, starting current is also constant. Then the torque and speed of induction motor can be controlled by changing the supply frequency where we gave to this speed torque characteristics of motors. We can notice from equation that at the rated voltage and rated frequency, the flux is the rated value. If the voltage is maintained fixed at its rated value while the frequency is reduced below its rated value, the flux increases. At low frequency, the reactance decreases and the motor current may be too high. This type of frequency control is not normally used. Come, let's go with changing the number of poles. The changing poles can be connected and inbuilt of the motor winding across both stator and rotor. This winding number of poles or windings are essential to smooth running system of motor. So it is very essential. Already we seen the previous videos. So I just give a small introduction about this changing the number of poles in the slide. This method is easily applicable to squirrel cage motor because the squirrel cage motor adapts itself to any number of stator poles. It is possible to have 1, 2 or 4 speeds in steps. By changing the number of stator pole, a continuous smooth speed control is not possible by this method. So the various limitation of this method are only step change in speed. So ns equal to 120 f by p. This is pole changing method. Winding connected across the motor of rotor and stator. So there is two connections. One is series pole connection, another one is shunt or parallel connection. This diagram is represented here. This is cascade connection. And this diagrammatical explanation also done by the previous slides. So no need to explain again. Thank you.